Okay, today we're going to look at exponential functions and what they're made up of, how to write one based on real world, based on a word problem, and solving the function itself. Before, I know you've got your notes, but I wanted to put this at the beginning to to get this part down first before we got into the notes that I gave you. All right. So you might want to get some paper and write this stuff down, at least some of them, so you can have some understanding of it when we go to write our exponential functions. Okay. So if you need to, hit pause and get some paper. All right. Okay. All right, so when we're looking at an exponential function, we said that the form is y equals a times b to the x. And c is after that. I'd call it c. I kind of added it myself, but what comes after your base and after your power, your base and your exponent, that's going to be your asymptote. All right, where it's approaching. But A, when we're looking at real world context, A is going to be your initial value. Okay, and we talked about yesterday, if B is greater than 1, then it's going to be exponential growth. Okay, so if B is greater than 1, then it's going to be exponential growth. So B is we're going to call that our growth factor. Okay, that's the factor we're going to use when you're finding your next value. All right, it's A times B to the X. All right, so B is going to be that value, that factor that's being multiplied. Okay, now R, you say, well, there's not an R in there. Well, we have a thing called growth rate.
Y'all tell Miss Blake I'll be right there. Mr. Evan, what's your location?
All right.
Your way right now.
All right.
Beautiful.
So the growth rate is included in the growth factor. All right. So your growth rate is included in the growth factor. In fact, your growth factor is 1 plus your rate. Okay? 1 plus your rate.
Down the hall.
Okay, so if I've got y equals 3 times 1.5 x, then 1.5 would be my factor. And if your factor is 1 plus your rate, well, if I take my b and subtract 1, that'll give me my rate, right? So my rate on this one would be 0.5. Okay? Your factor is the whole thing, and your rate is your factor minus 1. Okay? All right, let's look at decay. So decay is when we're decreasing, right? So same thing, A is going to be your initial value. And this guy, B is greater than 1. If B is less than 1, they had a typo on there. If B is less than 1, then it's going to be decay, exponential decay. All right. and B will be your decay factor, and R is going to be your decay rate. All right, so we said that B is our factor, all right? Well, your decay rate is going to be, since you're adding 1 plus R here, your decay rate is going to be 1 minus B. Okay, let me go up here to your factor. Your factor is going to be 1 minus your rate. Okay, B equals 1 minus your rate, so that means that your rate is 1 minus B. All right, let's do this. Let's say that I've got a factor of 0.75. Okay, my rate is going to be 1 minus 0.75, or 0.25. Okay, so for your rate on this one, up here in growth, you were adding it. It was whatever was over 1. Well, this is the amount that if you subtract it from 1, the difference. Okay. All right, let's do some examples here. All right, so here we got y equals 3 times 1.8 to the x. All right, first off, is it growth or decay? Well, it's greater than 1. Here's our b. This is a. This is b. So it's greater than 1, so it's going to be growth. Our initial value is here. It's 3. And our factor is all of b, which is 1.8. And then our rate, whenever we have a growth, it's going to be my factor, b, minus 1 is your rate. So 1.8 minus 1, 1.8 minus 1 is 0.80 is my rate. Okay? All right, well, let's look over here at this one. All right, 1.04 is our B. All right, so 1.04 is B. A is 2.14. All right, so B is greater than 1, so that means it's going to be a growth. Our initial value is A, or 2.1. Your growth factor is B, which is 1.04. And my rate, my growth rate, is going to be B minus 1. So 1.04 minus 1 is 0.04. Okay? All right, let's do a decay one. All right, so this one, this is A, this is B. B is a decimal, so it's like a fraction. It's less than 1, right? So that means it's decay. And our initial value is A, so it's 9. My decay factor is the whole thing here, 0.8, 0.80. And now my decay rate, all right, is going to be 1 minus B. Okay, your rate is 1 minus B. So 1 minus 0.8 equals 0.2. All right, just kind of look at it. What would I have to add to make that equal 1? Okay, because 1 is kind of like your your change, where it changes over from growth to decay, or decay to growth, okay? So if I added 0.2, that would make it 1, right? So 1 minus your factor, decay factor, will give you your decay rate. All right, let's look at another. Here's A, here's B. If I didn't have anything there, I wonder if I just had 0.94x, what would be my initial value? Well, it's understood that it's a 1 there, okay? So if there's nothing in front of it, then your initial value is 1, your starting point. And when we do the word problems in a minute, that'll make a little more sense. All right, so this is less than, so it's going to be decay. My initial value was 2. My decay factor is going to be B, which is 0.94. Sorry, y'all. All right, and then my decay rate is going to be 1 minus B. So it's going to be 1 minus 0.94, or 0.06. Okay. Okay. Let's look at this here. It says Selena's starting salary for her new marketing management job is $32,000 a year. She calculates her projected salary for the next 5 years by using the function y equals 32,000 times 1.12 to the x power. All right, so we know that this B is 1.12, so it's going to be growth, which makes sense because she hopes her salary goes up, not down. The initial value, so where's she starting out at? Her starting salary is 32,000. All right, that's why that is A. Okay. And her growth factor, this is growth, right? Her growth factor is 1.12, and her growth rate is going to be B minus 1. So 1.12 minus 1 is 0.12. All right, so that's 12%, right? So she's expecting that 1 is her base right there where it begins. Oh, sorry, y'all. So she's expecting her salary to increase 12% a year for the next 5 years. Good luck on that one. All right, so you can kind of see how it's makes sense in a word problem on this. All right, so let's look at some. Okay, so now it's your notes page. All right, so exponential growth. Y equals A times B, but instead of B, we're going to call it 1 plus R times T. Okay, so we're calling our variable T because in most of our word problems, it's dealing, your variable X is time. Okay, all right, so this is B. All right, so A is your initial amount. R is your growth rate, and T is time. Okay? All right, so this says that the original value of an investment is 14. So original value of an investment is 1,400. The value increases 9% each year. Use an exponential growth function to find the value of the investment after 25 years. Okay? Now you need to make sure that if you're using each year, when you're doing this, that your units of time match. Okay? All right, so let's write an equation. So we're going to say y equals A. What's our initial value? 1400, right? Times our B, 1 plus our rate. Well, it increases by a rate of 9%. How do you write 9%? 0.09. So B is going to be 1.09. So our factor is 1.09, and our rate, this is our rate, is 9%. Okay? And then we're going to put 25 here so we can find out what the investment is after 25 years. Okay? So if you plug this into your calculator, you're going to get that your investment's going to be 1,400 times 1.09 to the 25th power, or $12,072.31. Okay? All right. Let's look at the next one. The cost of tuition at college is $12,000. So the cost is $12,000 and is increasing at a rate of 6% each year. All right. So the function find the tuition cost after 4 years. So A, our initial is $12,000, her first year of college. Her rate is 6%, so 0.06. So that's going to make our factor. What's our factor going to be? 1.06, right? And then T, we're looking for, it's by year, so we're looking for 4 years. Okay? So our equation is going to be y equals our initial times our factor, which is 1 plus our rate, so 1.06, to the 4th power, because we want to find it for 4 years. Okay, so when you plug that in, you're going to get 15,149.72. All right, so this is what the tuition will be.
Where is Caden Patterson supposed to be?
So this is the
right now?
tuition. Oops. Tuition in 4 years.
Chevy has directed study, but he's absent today.
Okay, so that's the tuition, what the tuition will be in 4 years. All right, let's see. Let's go down. Okay. The population, see, it's rate of, the number of hours. Okay, let's look at this. Well, let's do this one. The population of a small town is 1,600 people. It's increasing at a rate of 3% per year. So find the population after 10 years. So y equals our initial times our rate. Times our factor. Our factor is 1. It's increasing, right? So that's going to be 1 plus our rate. So 1.03. And we need to find it after 10 years. Okay? Because it's at a rate of per year, so that's what your time would be. So we want to find it at 10 years. So our population in 10 years should be 2,150 people. Okay. All right, now let's look at this one. It says in 1985, there were 285 cell phone subscribers in Mayville. Wow, that's a lot of cell phones in 1985. Mayville must be a big town because not everybody had cell phones back then. I know I didn't get mine till 92. The number of subscribers increased. Okay, so it increased by 75% per year after 1985. Okay, it says find the number of subscribers in 2008. Okay, so our initial was 285, and it increased by a rate of 75% per year. So 1 plus 0.75, and they want to know what it will be. We're doing by years, right? T is years. So they want to know what it'll be in 2008. So we started out 85, so we need to go from 85 to 2008. So 85 to 95 to 2005 would be 20 years plus 3 more, so 23 years. So we should have 110,845,988 subscribers. Unless Mayville is a huge city, it probably started flattening out once you got past 98, something like that. Started flattening out. Okay. All right. So these have all been growth. So let's look at some decay. All right. So for decay, y equals our initial times b, which is going to be 1 minus your rate. Okay, so b is going to be 1 minus your rate, and t represents the units of time. So a is your initial amount, r is your decay rate, the rate of your decreasing, and t is your unit of time. All right, so the population of a town is decreasing at a rate of, important there, decreasing 1% per year. In 2000, the population, in 2000 there were 1,300 people. Use a function to find the population in 2008. All right, so our initial is 1,300 people, and it's decreasing, so it's going down 0.01. Okay, this is our rate. All right, so our factor is going to be 1 minus our rate, so it's going to be 0.99. Okay, so 0.99, and it says in 2008, so in 8 years, so y would be 1,200 people in 2008 would be our population. Okay. All right. So now when in real life, they don't clump together the growth problems and they don't clump together the decay problems. So you're going to have to really watch the increasing and decreasing. Increasing at a rate of or decreasing at a rate of. Okay? You have to look at what it's doing, all right, to determine, do I subtract my rate or do I add my rate to 1? Okay? All right, so the value of a car is $18,000. It depreciates at a rate of 12% per year. Depreciate means it goes down in value. All right, so we're decreasing. So we want to find the value after 10 years. So we started out at 18,000, and then we depreciate at 12%. So we're going to say 1 minus 0.12 per year. So that's going to be 18,000. And 1 minus 0.12 is 0.88. And we want to find it after 10 years. So that's going to be $5,013.02. So you paid $18,000 for it, and in 10 years it's only worth $5,013. Okay. Oh, let's see. Which one do we want to do next? I don't want to do it. Okay, an investment of $8,200 loses value at a rate of 2% per year. Use a function to find the value of the investment after 9 years. So it loses, so that means it's going down. So the initial was 8,200, and it's decreasing, so 1 minus 2%, 0.02 per year. So they want to find after 9 years. So 8,200 times 1 minus 0.02 is 0.98, and for 9 years. All right, so that's going to be $6,836.73. All right, if I was losing 2% every year, I would have cashed it out and gotten rid of it before 9 years, for letting it go for 9 years. But that's just me. That's why I don't do stocks, because I can't sit and let it just sit there and be patient for it to come back up. All right, let's do one more here, and then we'll stop. This is going to be a long video. All right, the population of the town. All right, we've already done a population. Okay, the initial value of a book is $58. And it decreases the rate of 7% per year. All right, so find the value after 8 years. So my initial equation is 58 times 1 minus 0.07 t. So I need to find it. 1 minus 0.07 is 0.93. And we want to do it for 8 years. So that's going to equal $32.46. Okay, that will be its value after 8 years. Okay. All right. All right. I hope that that first little initial thing helped a little bit as far as understanding what makes up the rate and the factor. So if it's a growth, it'll be 1 plus your rate will equal your factor B. And if it's decreasing, a decay, then it's going to be 1 minus your rate will be your factor, your B. Okay? All right. I will see y'all tomorrow. Have a good night.